Now, so example 5.1. And this he says that example 5.1. He says the magnetic field has a magnetic moment. How much? The magnetic moment is 6.7 into 10 to the power of -2 ampere meter square. This is the value of n. And moment of inertia I is given by how much? 7.5 into 10 to the power of -6 kg meter square. It performs 10 oscillations in 6.10 oscillations. It completes in how much time? 10 oscillations in 6.7 seconds. What is the magnitude of magnetic field? B is how much? So one oscillation will take how much time? Any idea? One oscillation takes how much time? 10 oscillations take 6.7 seconds. One oscillation. Very good. 1 into 6.7 divided by 10. How much it will be? 0.67? 0.67 seconds. Is that clear? This much is the time period. Means capital T is how much now? 0.67 seconds. He's asking what is the magnetic field. We have the formula here, right? T is equal to how much? T is equal to 2 pi under root of I by mb. This is the formula, right? I by mb. So this is the formula. Now we'll square it on both sides. We want B. See, we have T with us, we have I with us, we have M with us. We don't have B with us, and we have to calculate B now. First of all, we'll square it on both the sides. So what it will be now? T square is equal to what? 4 pi square into I by mb. Clear? Now we'll cross multiply this. B is equal to how much? 4 pi square I by how much? M into T square. Is that okay? Now, shall we substitute the values? So the value will be how much? B is equal to 4 into pi square means how much? Into 3.14 whole square into I is how much? Moment of inertia is given there. 7.5 into 10 to the power of -6 divided by what we need? M and T square. What is M now? M is 6.7 into 10 to the power of -2. What is T? Time period is 0.67. Okay, so 0.67 whole square. Okay, so these are the values. When you take substitute all the values and solve it, okay, we'll get the magnetic field value. Clear? Yes, sir. So see here. So B is equal to how much? B is equal to 4 into 6.28, 3.14, 3.14. How much? 9 point how much? If you square it, it becomes 9 point something into 7.5 into 10 to the power of -6 divided by 6.7. So also if it is 6.7, it will become 6.7 whole cube. Okay, so 0.67, or we can write 6.7 into 6.7 into 10 to the power of -2 becomes -4. -4. So 3.14 into 3.13. How much? 4, 4, 16, 6, 1, 4, 1, 4, 5, 4, 3 is 12. 3 more. Then 1 means 3, 1, 4. 3, 4, 12. 1, 3, 1, 3, 4. Then 3, 3 is 9. 6, 9, 5. So it will become how much? 1, 2, 3, 4. 1, 2, 3. So it will become 9.85. 9.85. Okay, that is a way we multiply. Okay, and then simplify it, you will get the answer. So it is showing the answer is one B is equal to 0.1 second again. 0.1, 0.01 Tesla. 0.01 Tesla. Yeah? This is the one. We'll solve next question. No? Huh? Correct. Yes, sir. Okay, next question. A short bar magnet placed with its axis 30 degrees with an uniform external field of 800 Gauss. Okay, now I'll erase this. A short bar magnet placed with an axis, that is 5.2. Like suppose this is the magnetic field, okay? The magnetic field B and the short, this is a bar. Okay, the bar magnet is placed at an axis 30 degrees. Okay, like this. In this, yeah, 30 degrees with the axis. Now, the magnetic field B is how much? B is equal to 800 Gauss. But we have to convert this into Tesla. We cannot just leave it like that. Okay, there are two units of magnetic field in which we can measure. One is Gauss and one is Tesla. So, but we have to write in Tesla. Clear? So we'll convert them. So one Gauss equal to how much? 10 to the power of -4 Tesla. So this will become how much? B is equal to how much? 800 into 10 to the power of -4 Tesla. Yeah. Now our experience is a torque. How much is the torque? Torque is equal to 0.016 Newton meter, and angle theta is equal to how much? 30 degrees. Okay, this is the angle. Now, what is the magnetic moment of the magnet? He's saying the first question is magnetic moment M equal to how much? What is the formula for M? What is the formula for M? We'll use the formula. So first one, the formula is tau is equal to mv centimeter based on the given values. See, we have two formulas. M is equal to NIA. Is that clear? Yes. Magnetic moment M is equal to NIA. Now we have the second formula tau is equal, because I have B, I have tau, so I have to use that formula to find out M. Tau is equal to mb sin theta. M equal to how much? M equal to tau by B sin theta. Okay. So now how much it is? M equal to tau is how much? 0.016 divided by B. What is B? 800 into 10 to the power of -4 sin theta, sin 30 degrees. Okay. Sin 30. Clear? So the value of M is equal to how much? M equal to 0.016 divided by 800 into 10 to the power of -4 into 1 by 2. So M equal to how much? 0.016 into 2 divided by 800 into 10 to the power of -4. Okay, the 2 will go up, it will become like this. Is that clear? So, so M equal to how much now? See here, can we write here like see 16 into 2 into, can we write 1, 2, 3, 10 to the power of -3 here? Can we write like that? 16, I'm writing 16, 1, 2, 3, no? 10 power -3. Okay, shifting that. Okay, and here 8 will become 800 into 10 to the power of -2. Can I write like this? 2 zeros I'm removing. So 8 ones, 8 twos. Okay, got it? So M equal to how much? 4 into 10 to the power of -3. This minus will go up, becomes plus. So M equal to how much? 4 into 10 to the power of -1. Can I write 0.4? 0.4 ampere meter square. This is the unit of the magnetic moment. Is that clear? Yes. So try to make as simple as possible. Don't try to keep on multiplying and dividing. It becomes laborious process. Never do that. Okay. The second one, what he says is what is the work done in moving it from the most stable to most unstable position. Most stable is how much? 180 degrees. So see, when you see here, example, the second one, see, suppose this is the magnetic field. Okay. He says most stable to most unstable. Okay. Means what? The magnet is like this. This is North Pole and this is South Pole. This is the stable position. Okay. Very stable position. How much is the angle here? Theta is equal to theta equal to the angle between the magnet and the magnetic field. How much it is? Same direction. No? How much degrees? Aaron. Theta is equal to how many degrees?
90.
What is the angle between this line and this line? They are parallel. No? Parallel means 0 degrees. Very good. Theta is equal to 0 degrees. Is that clear? If they are in the same direction, angle is 0. This is the road. I am also moving in the same direction. Means what? 0 degrees. Now, most unstable position. What do you think? Which is the most unstable position for a magnet now in this situation? If the north is here and south is here, it is an unstable position. Means it cannot turn now. Suppose, example, see, the wind is coming opposite direction. Now, suppose I am standing in the direction of the wind, that is 0 degrees. Okay. Okay, that's okay. That is 0 degrees. But wind is coming against me. I cannot turn. It's very difficult now. Okay. Very heavy wind is coming towards me. It's very difficult to turn now. Okay, clear? So that is 180 degrees now. So now suppose this is the magnet now. B is the magnetic field and this is the magnet. Okay. This is north and this is south. Okay. So theta is equal to how much? Here theta is equal to 180 degrees. Is that clear?
Yes.
So what is the, he's asking, what is the work done to move the body from mostly highly unstable to highly stable? Highly stable to highly unstable. So final minus initial. Generally work done is how much? Energy when theta is equal to 180 degrees. Final minus initial. Okay. Is that clear? Energy, see, work done and energy are same. Keep that in the mind. They are having the same units. Work done is also measured in joules. Energy is also measured in joules. Both are measured in joules. So U is equal to 180 degrees. This is the final position. To initial position. Final position minus initial position. Is that clear? So what will happen now? W equal to what is the energy formula now? Energy formula is M dot B, right? Energy formula is MB. Okay, M dot B. So we write here MB. Actually, the formula for I write here. That is equal to minus M dot B, or it is also written as minus MB cos theta. Okay. Is that clear? Clear? Yes. Now cos 0 is how much? Cos 0 values. What happened?
Charles is calling. Video calling.
Just give it to me.
Dude, actually.
Let me speak to sir directly. Sir is here. Hello Ashas, how are you? He disconnected. Hello Ashas.
Very good morning, sir.
Very good morning. How are you, man? Where are you?
Sir, I'm outside, sir. Tomorrow I'm coming to Dubai. So, little busy, sir.
Ah, very busy. Huh? Okay. You have time to call. Huh? Okay, okay. Enjoy.
Sorry, sir. I'll attend this tomorrow. Yeah, tomorrow.
Okay. So, what is cos 0 value?
No, one.
I will write it here. Okay, for your convenience, I'm writing here sin x value and cos x value. Okay. 0 degrees, 90 degrees, 180 degrees, 270 degrees. Somewhere you can write at the last. Okay, so that it will be easy for you. Especially for bio students, it is difficult. Okay. So sin 0, 0, 1, 0, minus 1, 0, 1, 0, minus 1, 0, 1. Done? Plus. This you have to learn. Okay. Now cos 0 value is 1. Cos 0 value is 1. Okay. And cos 180 value is how much? Minus 1. Very good. Shall we substitute here now? U is equal to, we write minus MD cos 180 degrees minus, again, minus MD cos 0 degrees. Okay. Now, U is equal to how much? Minus MD cos 180 is how much? Cos 180 is minus 1 minus MD What is cos 0 value? 1. Is that okay? Are you understanding? Now minus of minus will become minus into minus plus. Very good. Again here minus into minus plus. That is how we got MB plus MB is 2MB. Got it? In the textbook he got like this. Sometimes what you will think now, students while they are doing with their own, maybe they have taken magnitude. That is why MB plus MB became 2MB. In the textbook he got directly 2MB here. See, 2MB directly here. We think students think, oh, he is taking magnitude. When to take magnitude, when not to take magnitude. Okay, that should be, we should be very careful. So 2MB. Okay, so U is equal to 2MB. How to substitute the value also? What is that? 2 into what is M now? I think 0.4. 0.4. What is B here? B. What is B? 800 into 10 to the power of minus 4 Tesla. 800 into 10 to the power of minus 4 Tesla. Then you will get how much? The magnetic. How much it is? 0.064 joules. 0.064 joules. Yeah? Take it. Just clear this numerical. Still third part is still remaining. Yeah, one more part. Okay, we'll do that. Then I will explain you electrostatic analog and magnetostatic analog. Okay. Are you able to see, man? From there. Okay. This is only for them, just recording. I don't know whether they will see or not.
They won't see.
But I am doing my Today also your classes are until 9 now.
No,
Carry some food, okay?
the problem is as soon as you open the food, everyone jumps in.
Now it is okay, but once the school started, it will be very hectic.
So if you have to go outside India, it's higher studies, MBBS, you don't have to get NEET.
Need you have to write. You have to discuss with her, okay? My wife, she will explain. She is very good at this. More than me, okay. But her students are in US, Canada, Malaysia. She will help you because she was working, she was visa officer. There are some, I think, you don't pay anything for any consultancy. Suppose some people will say you pay something, will explain, no, don't pay anything. Actually, the good ones, the genuine ones will never take any money. Actually, the university will pay them the money. It's like that. When you suppose you are going to enroll in XYZ University in London, they will, that is their agency. It's like that. Okay. So when you are free, just sit with her, she will explain. You know, what is her name? Sanika.
Yeah.
Sanika was having so many times. I said, you call her. She spoke to 1 hour, to her 1 hour, 1 hour or more than 1 hour. She cleared all her doubts. Your rules for every country is different. So
I don't mind continuing in development.
don't do here. Don't. My advice.
Because Abu Dhabi does this university, or American university. So once he went to a doctor, so with my mom, so his son is also studying.
I don't recommend. Okay. I don't recommend because better go to some foreign like US or UK, like that somewhere. Yeah, their medicine is very advanced. Okay, not,
Because I don't want to go to India.
no need to don't. Who is asked? Who is
My dad is sick.
I visited recently to my place. You know, there's a main junction. From there, we have to go like this. It is around maybe half a kilometer or more than half a kilometer. Here, when I started from here, from the junction to my place, all there are hospitals, hospital, medical center, diagnostic center, hospital, medical center, diagnostic center, pediatric, orthopedic, all are the like line.
Yeah.
Once upon a time, there used to be schools and book centers. No, everywhere. I asked my mother, what is this? No, she told me our area is top area. No? Too much, no? Okay, so shall we do the third one? Okay. I just move it, man. If you want, cannot able to see. You can see the regulation. Water is there over there or how it is? But better carry water there. Don't do
I like the buy or I like
better. Water is a source of many diseases, you know.
personal experience with this.
No, I had a jaundice when I was in my PhD. I was doing a research. No? First I had a fever. After that I got a jaundice, yellow jaundice for 3 months. Again white jaundice, continued 3 months. 6 months I was on medication. No, the doctor told me it's because of the water. And jaundice is a disease which you will not never. There is no symptom actually. Unless and until the old people, no, they check the nails and this risk. Best example is the wrist becomes black whenever you experience this, like this becomes yellow and eyes become pale. These are the only thing, and only old people who are very good at that they can identify. Otherwise, it is very difficult. Only with the blood test otherwise. You know, identify this jaundice disease. And also, it only these symptoms will come only after 50% of the infection. You know? After that, it enters intestine. Once it enters intestine, no one can save. Okay, done. So we will go to the third one. He's asking M is equal to what is the magnetic moment? Okay. So M is equal to NIA. Okay. So the formula here is M equal to small m is equal to what? NIA. Okay. So M equal to what? M is given here. He's asking number of terms. There are 1,000 terms. Okay. A is also given to us. Sorry. M equal to NIA. So we have small m. What is small m is 0.4 ampere meter square. And he is asking the bar magnet is replaced by solenoid, but the determine the current flowing. I is equal to how much? I is equal to how much? And is equal to number of turns, which is 1,000. 1,000 turns are there, and cross section is 10 power minus 2. 2 into 10 to the power of minus 2 meter square. 2 into 10 to the power of minus 4. Sorry. This is the cross section area. So m is equal to NIA, I is equal to m by NM. Okay. M is equal to 0.4, N is 1,000, and area is 2 into 10 to the power of minus 4. Okay, solve it. You get the current. Current is how much now? It's coming around 2 amperes. Okay, what will solve it here? Okay, 4 into 10 power minus 1, and here 2 into 10 to the power of 3 is there. See, 3 zeros are there. This is minus 1, becomes minus 1. Okay, so see, this and this will go away. 2 ones to 2. Answer is 2 amperes. Okay. Don't multiply and waste your time. Multiply, divide, and all. Okay, just zeros. Play with zeros, 10 powers. Okay. Okay, I'm starting with electrostatic analogy now. Then we'll discuss about the magnetism and Gauss law. So magnetism is magnetic flux. Basically, it is magnetic flux. Then Gauss law. We'll discuss about that. Okay. Any doubt in this? You have to do. You have to try some more numericals also on this. And also, please keep on checking the syllabus. If anything outside portion is there, like out of portion, please tell me. You have to check and you have to tell me because I don't have any idea now. Like every time it's changing. Okay. Now, oh sorry. Did you write this? Okay. Okay. Now, here we have the electrostatic analog. electrostatic analog. We are going to compare electrostatic to magnetostatic. Okay. So we have electric field and magnetic field. Okay, the field I am saying. So if it is electric field, electric and magnetic. For electric field, we write capital E. Okay, for magnetic field, write capital. Here, electric field, we write capital E. For magnetic field, we write capital E. Next is dipole moment. Okay, dipole moment. So if it is in case of electric dipole moment is P. Magnetic dipole moment is, or magnetic moment is M. Very good. What is the formula for P? Electrostatics. P is equal to, what is the magnetic moment formula? M is equal to NIA. Very good. Just now we did, no? M equal to NIA. Okay. Next one. Permeability. Okay. Permeability or permittivity. Okay. Permeability or permittivity. Okay. Permeability for what? Permittivity for electrostatics. Permeability for magnetostatics. Okay. So here we write 1 by 4 pi epsilon 0. Here we write mu 0 by 4 pi. Here. Next one. So the axial line. What is the formula for axial line? Axial line is what? E is equal to EA is equal to what? 1 by 4 pi epsilon 0 into 2p by r cube. Okay. For magnetism, what is that? dA is equal to how much? Mu 0 by 4 pi into 2m by x cube. Okay. 2m by x cube. Similarly, for equatorial line, what is the formula? For equatorial line, what is the formula? EQ is equal to what? 1 by 4 pi epsilon 0. We are just equating, no? Just comparing. R cube minus p by r. Okay, minus. Here, B for equatorial line, the formula is what? Mu 0 by 4 pi into m by r. Now, I'll go for energy and then torque. Okay. What is the formula for torque? Tau is equal to mb. Very good. Minus only mb. M dot m cross mb sin. So torque tau is equal to p cross e, and here it is tau is equal to m cross b. Okay. What is the energy formula or work done? U is equal to minus m dot b. This is p dot e or minus p dot e. P dot e. Okay. So these are the comparisons. Okay. If you learn one, you can learn the other one. We'll try one question here. Okay. For energy also it is minus p dot e. Okay. Not positive, it is negative. Minus p dot e. We'll do a numerical on this now quickly. Here we can write 1 by epsilon 0. Here we can write mu 0.
So it is minus p dot e.
Minus p dot and minus m dot. Now we'll do one more numerical. Okay. Now example 5.4. So what is the magnitude of the equatorial and axial fields due to a bar magnet of length 5 centimeters at a distance of 50 centimeters from the midpoint? Okay. So here the value is, he says the length of the bar magnet is, what should I write? Example 5.4. Length of the bar magnet is 12. How much? 5 centimeter. That is 5 into 10 power minus 2 meters. And R is equal to how much? 550 centimeter. R equal to 50 centimeter from its midpoint. The magnetic moment of the bar magnet is how much? M equal to 0.40. M equal to 0.40 ampere ampere meter square. This is the value. Okay. Now what he says, you have to calculate the axial line and equatorial line. Okay. And he said the same. Just take the same values of example 5.2, the previous problem, whatever we have done. Use the values from there he's saying. Okay. Now B is equal to, for what is the formula for axial line? Axial line is mu 0 by 4 pi into 2m by r2 or 2m by x2. Okay, just substitute the values. For equatorial line, what is the formula? Mu 0 by 4 pi into 10m by x2. What is the formula for value for mu 0 by 4 pi? Mu 0 by 4 pi value is how much? 10 to the power of minus 7. Okay, 10 to the power of minus 7. That's the value. Okay. Substitute the values. You have the m value, no? M is already given to you. X value is given. Don't take 50 centimeters. What you will write there? 0.5 meters. It is in centimeters. Convert that into meters. Okay. We can X. For this we write X. Okay. Here I wrote R. No. For magnetism it is X in the place of R. This is silencer one. Silencer. When the bike was there, I was keeping water bottle inside. It fell down. Then after parking, I just was trying to take the bottle, and suddenly the silencer hot. I put that water on that, it became hot. Yeah, same. Irritates a lot.
Scooter.
No, the bike. The
No, no.
bottle was there, it fell on the other side of the bike. So I was trying to pick up the bottle. I forgot about the silencer.
I got one while riding the bike.
Uh,
The infield silencer is so big.
so that's finished.
Yes,
Got the answers? Substitute the values and get the answers. What time you start from home? What time you have to reach there? Half an hour you reach? How will you?
Oh, from my friend that it's a my dad.
Okay. NEET you have to write. It is compulsory. She told me. Even I was not knowing. NEET is compulsory for if you want to go to US or UK, any country, foreign country, you have to definitely NEET. So try to start in do this medicine in foreign country. Because see, even I will give she told me one example. Like those who do MBBS in India, in UK or US, they have to again do that exam again. Otherwise, they have to write some exam systems. If they clear those exams, then only they will be eligible for MS something like that. So better why to again, anyways, masters you want to do there. So better for it. See, here if you work for 20 years also, they are not going to do citizenship. Max they will be golden visa. Okay, so better if you go to Australia or somewhere, you get a citizenship. There are many, the advantages. Okay, better Canada or
Can I
UK.
have a lights?
Huh?
Can I have a lights?
Yeah. You can take. I'll send you my landline number also. Both the numbers also. Allen number. You can also take a number. If it is 06, I like it. You can take down my Allen number. 675. So this is my time. Anytime you can solve it. So okay, so shall I go ahead with the flux or should you want me to stop here? Okay, okay. So tomorrow I will do flux. Okay, the two things I have to discuss tomorrow. Topics of flux, cost of magnetostatics. Then earth magnetism is deleted from the portions. Earth elements also is deleted from the portions. Only magnetic properties of material. In that you have three: diamagnetic, ferromagnetic, and paramagnetic. And then last one is electromagnet and normal magnet, permanent magnet, electromagnet. This BH curve is important. This came in IIT exam also. This curve that we will discuss finish. So maybe half an hour max. After that, we'll do numericals of this lesson. Okay. Yeah. So see, my intention is before today is what 7. At least by 20th. Not I'm not taking 22nd. At least before 20th, I will try to complete as much as possible. Alternating current EMI and I'll try to at least start electromagnetic waves also. We can one day it requires only electromagnetic waves. Not even one day. We can finish off the electromagnetic waves. Okay, very small chapter. One class we can finish off the remaining AC current and EMI. EMI also have started. The Faraday's law, Lenz's law already started. So that conservation also we have started. Only mutual induction, self-induction is pending over there. Once I'm done with this, finish that chapter is done. Okay. So mostly 5 days or 5-6 days we will finish off this one. Okay. Thank you so much.
Thank you.
Welcome.